Hi scholars, welcome to the video on domain and range. Don't forget about your Cornell notes. You want to start by dividing your paper into 4 sections. Right across the top, you're going to put the topic heading, which today will be domain and range. You might also want to put today's date. Section 2, a line about 1.5 inches from the left side of your paper is going to be for any questions that you might have. Section 4, 4 or 5 lines from the bottom of your paper, is for a summary of the main arguments and key concepts. And section 3 is where you're actually going to be writing your notes for today. Go ahead and start a new topic heading called domain and range, and we're going to start with some vocab. Go ahead and write domain. Domain is the set of all x values for which a function is defined. So we talked last time about how a function is a special type of math relationship where for each input there is exactly one output. The range of that function is the set of all y values for which a function is defined. And we'll give you some examples of that in just a minute, but go ahead for now and pause the video until you get your vocab written down. So here's an example of a function. It's a function because each input has exactly one output. 0 only matches with 2. 3 only matches with 4. -3 only matches with -2. And 2 only matches with 4. We don't care that the 4 is repeat. Remember, the definition of a function is that each input has exactly one output. So when we say a set, we're talking about a group of numbers. If I want to list those, I use what I call the squiggly bracket. You don't have to make a perfect squiggly bracket. It is perfectly okay if you're not sure what to do, just to make a squiggle and we will know what you mean. That is our indication that we're about to show a set of numbers which go together. So for this example, the domain are just the x values for this function. So 0, 3, -3, and 2. But you will often see these written in numerical order. So if I put these in order from smallest to largest, it's -3, 0, 2, and 3. And we close that with another squiggly bracket. That's our domain because it comes from our input, our x values. Our range is the set of all of our y values. So we're looking at our y values here. The y values are 2, 4, -2, and 4. If I put those in order from smallest to largest, though, this becomes -2, 2, and I don't need to repeat that additional 4. It's just telling me that 4 is a value for which the function is defined on the y-axis, and so I can just write that one time. It's not necessary to repeat. So essentially, the domain of functions are your possible x's, the range of functions are your possible y's. It gets slightly more complicated though when we want to find the domain and range of something that looks like this. So we want to look at all the possible x values and all the possible y values of this graph. So if I want to do my domain, I could make a list of all my possible x values from smallest to largest. So if I follow this down, the x value that's farthest to the left is -10. Then this curve stretches all the way. If I go from left to right, there are possible values at -9, -8, -7. But there are also possible values at -7.5, -8.5, or -7.1. It doesn't make sense to try to list all of those. So I don't want to do this using set notation. I want to use an inequality, a compound inequality that can show in between. So we can put our x in the middle, and I can see that these x values stretch all the way from -10 on the left all the way up to 9 on the right. To show in between, we always use less than signs. -10 is the smallest, everything else is in the middle, and 9 is the biggest. Everything else is smaller than 9. And then on each end, this is a shaded in circle, this is a shaded in circle, so that indicates that I need equal to signs there. The range are the possible y values. Sometimes people are helped if they turn their paper on their side. I know that's hard for you because this is on your screen, but you want to think about this as being from bottom to top, the smallest y value. This is actually not our smallest y value. The blue line curves under that. Our smallest y value is right there. That y value, if I follow that over, is -1. The highest y value is right here, and that's at 4. And y is in between those. So the smallest y value is -1. The largest y value is 4. So -1 is less than y is less than 4. And then these are actual lines, curves there, so I can use equal signs there. If for some reason there was a break in the graph somewhere, then we wouldn't use an equal to sign there. But since it's a part of the curve, we use an equal to sign. So we're going to use compound inequalities to help define our domain and range of our functions if I can't make a whole list. Let's try another one. Find the domain and range of the function. So the domain are your x values. The range are your y values. And you want to show in between. So we're going to use these less than signs. So let's look at our x values. Remember, your domain is your left to right. So there's my farthest stop to the left, and on the x-axis, that's at -8. On the y-axis, it goes all the way over here to +10. All right, so on the -8, do you think we need an open circle or a closed circle here? Well, it's a closed circle, so we need a line underneath. This one's an open circle, so we don't need the line underneath to indicate that it's equal to. It is not equal to 10. The range can be a little harder to see sometimes. I'm not sure if the lowest point is here or here, but maybe it doesn't matter. Let's follow it over to the y-axis. It looks like our lowest point is -6. And remember, that was a shaded in circle, so we use a line there. Our highest point is a little easier to see if we follow that over to the y-axis. That's at 4. And I don't need a line on that. So our domain is in between the numbers -8 and 10. Our range is in between the numbers -6 and 4. A line can be a little different. Remember, these arrows indicate that these lines are going off into infinity. So our domain is from -infinity all the way up to +infinity. We never use equal signs underneath for these because we're never actually going to reach +infinity. The range also goes from -infinity, ooh, sorry about that terrible infinity sign, all the way up to +infinity. Remember that laying down 8 is what stands for infinity. All right, pause the video, make sure you have all this written down before we move on. One of the things that we're going to be talking about is finding reasonable domain and range. So let's start a new topic, underline it, and it's called finding reasonable domain and range. It's always a good idea to write at least part of the word problem down in your notes so that you have something to refer to. So I would make sure that we write the function. So that's our equation we're going to be using. They're telling us it's a function. It represents the height of the objects above the ground. So I would write that down. The function represents the height of the object above the ground. And I would definitely write down that x stands for seconds after being launched. We want to talk about reasonable domain and range. It's not often in life that everything goes from -infinity to +infinity. For example, if you were asking how much money are you going to spend on something, there's probably a reasonable number in there. It's going to be more than 0 if you're going to spend money on something, and probably less than 1,000,000. Okay, so there are reasonable numbers. We can substitute in numbers to kind of reason out for ourselves what a reasonable domain and range would be. So we're going to start by finding f of -1. So if you remember when we learned about function notation, we're going to substitute -1 for x. So this becomes -16 times -1 squared plus 16 times -1 plus 672. You want to follow your order of operations. -1 squared becomes +1, so that becomes -16 times +1 plus 16 times -1 plus 672. -16 times 1 is -16. 16 times -1 is -16, and then we're going to add 672. -16 and -16 is -32 plus 672. And the signs are different, so I'm going to subtract. So 672 minus 32 becomes 640. So remember, X stood for seconds after being launched. So what that's saying is X is equal to -1. X seconds after being launched, that seems like not a reasonable number. And then the Y value, the height at that time, is 640 feet. So what we've got is -1 seconds and 640 feet. We're going to keep that in mind, and we're going to try another one. Let's try f of 4.5. Oh, I'm sorry. F of -1 equaled 640 here, meaning that -1 seconds after the object was launched, the object was 640 feet above the ground. This interpretation is not reasonable. It is not reasonable that -1 seconds ago something was happening. We cannot go back in time. It is not reasonable because -1 is not a reasonable domain for time. Let's try something different though. Let's try f of 4.5. So it's going to be -16 times 4.5 squared plus 16 times 4.5 plus 672. So I'm going to square 4.5 first, so I'm going to get out my handy dandy calculator. I'm going to do 4.5 times 4.5, and that gives me 20.25. So that becomes -16 times 20.25 plus 16 times 4.5 plus 672. -16 times 20.25 is -324. 16 times 4.5 is 72 plus 672. -324 plus 72, the signs are different, so we subtract, take the sign of the larger number, so that's -252 plus 672. Signs are different, so we subtract. 672 minus 252 is 420 feet. So let's talk about what that means in the context of the problem. When I substitute in 4.5, I got 420 for that, meaning that 4.5 seconds after the object was launched, the object was 420 feet above the ground. This interpretation is reasonable. I can launch something and wait 4.5 seconds to see what happens, and 420 feet above the ground is a reasonable number. Let's try f of 12. So we're talking about 12 seconds. Let's see what's happening 12 seconds after we launch. So we're going to do 12 squared, which is 144. I'm going to do -16 times 144. That gives me, oops, I think I typed that in wrong. 16 times 144 is -2,304. -2,304. Oops. And then 16 times 12 becomes 192 plus 672. Signs are different, so I'm going to subtract 2,304 minus 192. Take the sign of the larger number, so that's -2,112 plus 672. Signs are different, so I'm going to subtract again. Take the sign of the larger number, so that's -1,440 feet. All right, so let's take a look. F of 12 is equal to -1,440. Meaning that 12 seconds after the object was launched, the object was -1,440 feet, and that's actually not above, that's below the ground. If the number here is negative, that's below the ground. This interpretation is not reasonable. That is not a reasonable interpretation in the context of the problem. So based on what we just did, let's now try to select a reasonable domain and range. So when you are asked to choose an appropriate domain, it's going to give you a drop-down menu here. So the first thing it asks us is, could it be all real numbers? No, we already said that there are some things that, remember, domain is our x, that are not appropriate for x. We cannot go backwards in time. We cannot go backwards in time, so we don't want negative numbers there. Maybe it's non-negative real numbers. That's a possibility. So if we can't be negative, maybe this one is a possibility. Maybe it's real numbers in between two different numbers. That's also a possibility. It can't be integers though, because integers have negative numbers. Let's think about whether it's reasonable for time to be whole numbers. Could we have parts of a second? Could we have 0 seconds and 0.5 seconds and 1.2 seconds? Yes. So it can't be whole numbers. We already said that x can't be negative, so it can't be the integers because x can't be negative. So that leaves us with two options. If we say non-negative real numbers, that means it could be anything 0 and above. Well, remember when we got to a certain point and then the object went under the ground? It can't be all the non-negative real numbers. It needs to be real numbers in between some value of a and b. So we would say an appropriate domain is real numbers between a and b. We don't need to know more about that. They just want us to think about sets of numbers and where those should be. All right, in your summary section, that line at the bottom, I want you to define domain and range in your own words and be ready to share out. Don't forget that you need to be ready to show your notebook during a notebook check time. Have a great day.